All right, so we have talked before about how if I have some function f of x, right, and let's say here's all its domain values and here are all the range values, right, then what we would do to generate f inverse of f, right, is we would take all of these domain values and make them the range values over here, and take all these range values and make them the domain values over there, right? So in other words, in the domain over here, if I had this value 2, which after I applied f to it got me to the point of 7, what that means over here is that 7 will then be one of my domain values, and when I apply f inverse to it, I should get the point 2 right back, right? So again, what we are doing is we are switching the domain and range values, right? And of course, the way we're used to thinking about that is, the domain values are my x's, my range values are the y's. So what we're doing is we're switching our x's and the y's. That's the process that we're going to do in order to figure out what the inverse is. So let's start off with an easier one here. Let's say I have f of x equals 2x minus 6. Okay? Or if you rather, y equals 2x minus 6. What we'll do to find the inverse is we will switch the x and the y values, right? And then what we can do is solve for y, right? So if I switch my x's and y values, this would become x equals 2y minus 6. And then I could add 6 to both sides, get x plus 6 equals y, 2y, and then divide both sides by 2 to get 1/2 x plus 3 equals y. Right? And then this is what we are going to claim is f inverse of x. Okay? So I have f of x equals 2x minus 6, and I claim that my inverse is 1/2 x plus 3. Okay? So I guess the question then is, how do we actually check to see if this is actually going to work? Right? Well, the idea is not too bad, because if you remember, inverses undoes everything that the original function does, and I guess it would be vice versa as well. Right? So in other words, if I started off with some function f, and if I say what's f of 3, right, then we plug 3 into f. Right? What we're going to do here to check this is I'm going to take my function f, and I'm going to plug f inverse of x into it. And if you think about what this means, it says take x, right, plug it into f inverse, and then whatever result pops out from that, plug it into f. Right? So in other words, I'll take x, plug it into f inverse to get something, and then take that result and plug it back into f. Where should we be? We should be right back at x. So that's one check that we can do. And the same argument goes with the other side. If I take f inverse and I plug f of x into that, again, they should undo each other, and I'm left with x. Right? So these are the two checks that we need to do in order to make sure our function actually has an inverse and that we found it correctly. If we get anything else on either one of these checks, then we know that we did it wrong. All right? So let's check these two and see what we get. So I claim that if I had this function f of x equals 2x minus 6, that the inverse turned out to be 1/2 x plus 3. Right? So let's see what happens when we plug each of those into it. Right? Check their composition. So what is f of f inverse of x? Right? What that means, again, is everywhere we see an x, let's make it f inverse. So this is going to equal 2 times f inverse of x minus 6. And f inverse of x is 1/2 x plus 3. And then if you distribute that 2 times 1/2 gives me a 1x, 2 times 3 gives me a 6, and then I still got that other minus 6 there, and those 6's add up to 0, so I am left with x. Right? So the first check holds. Now let's check the second one. What happens if I take f inverse and I plug f into that? Well, that should be 1/2 times, and in this case, I'm plugging in right here. So it would be 1/2 of f of x plus 3. So that's 1/2, and f of x, if you remember, is 2x minus 6. And if you distribute the 1/2, you get an x minus 3, and then you've still got that plus 3 hanging out there. So those add up to 0, which leaves me with just x as well. Right? So both of those checks work out, so I know that we found the correct inverse for f. Okay? All right, let's try another one here. Make it a little bit tougher. What if f of x equals 2 over x minus 3 plus 4? Okay? Then how can I find the inverse here? Well, again, let's say y equals 2 over x minus 3 plus 4. What I could do is I could take the 4 over to the other side to get y minus 4 equals 2 over x minus 3. And at this point, don't forget, we still need to switch the x's and the y's. We can do that now. We could have done it at the beginning, and that's okay too, but let's go ahead and switch them now. So now I'll have x minus 4 equals 2 over y minus 3. Okay. So what we could do is I could rewrite this as x minus 4 over 1 and then cross multiply. Okay. And what that'll give me is x minus 4 times y minus 3 equals 2 times 1, which is 2. All right. Now remember, I'm trying to solve this for y. So let's go ahead and multiply this out and then isolate the y variable. So if I FOIL this out, take the x times everything in here, I'll get an x times y minus a 3x. And if I take the negative 4 times everything in there, I get a negative 4y and then a positive 12. So that's the left-hand side, and remember that's going to equal 2. All right, let me get a little more space here, and let me go back up top. So if I try to isolate the y's, let's keep all the y's over on the left-hand side, and let's take everything else over to the right-hand side. So that negative 3x becomes a positive 3x, that negative 4y becomes a positive, oops, just kidding, I didn't take the 4y over. That positive 12 will become a negative 12, and then don't forget you still got that other 2 on the other side. So I have x times y minus 4y equals 3x minus 10. Right. So to solve for y, let's factor out that y to get this, and then to solve for y, let's just divide both sides by x minus 4. Right? And then this is what I'm claiming is the inverse for f right there. Right? So we'd say f inverse of x equals 3x minus 10 over x minus 4. All right. Let's see if we can turn it up a little bit more even. What if I gave you this function, f of x equals 2 plus the square root of x minus 4. Okay. So in other words, let's switch over to y equals 2 plus the square root of x minus 4. All right, let's see if we can find the inverse. Okay. So again, first step we're going to do is let's switch our x's and our y's. And then I need to try to solve this for y. So let's isolate that by taking the 2 over to get x minus 2 equals the square root of y minus 4. And then I need to get rid of that square root. So what we can do is square both sides. Okay. And if we do that, then the right-hand side's easy. That's just going to be y minus 4. And the left-hand side, right, if you take x minus 2 and square it, it's just x minus 2 times x minus 2. Okay. Which, if we FOIL that out, gives me an x squared, a minus 4x, and a plus 4. All right. And then if I go back up here, if I just add 4 to both sides, I would have x squared minus 4x plus 8 equals y. So there is my inverse. And I would claim that f inverse of x equals x squared minus 4x plus 8. Right? And if we really wanted to, we could plug those in there and check and see what they're going to be. All right, so that's how you can find an inverse, right? So if I gave you some function f of x and I asked you, does it have an inverse, right? You want to check to make sure that it's 1-to-1. Okay? And if it is 1-to-1, that means it does have an inverse. And then the way you find that inverse is we just switch the x and y variables. So again, every x you see, make it a y. Every y you see, make it an x. And then once you have that done, solve it for y. And whatever result you get is going to be your inverse. All right, so the last idea I want to share with you all is, what do these inverses actually look like? Okay? So let's keep with this same function. Okay? So we have f of x equals 2 plus the square root of x minus 4. And we just found the inverse to be x squared minus 4x plus 8. Okay, let me get rid of this. And what we can do is we can start to graph these things using our transformation properties we've been messing around with. For instance, for the inverse over here, if you complete the square on this, this becomes x minus 2 squared plus 4, right? Which, if you remember, this starts off with our base function of x squared, which is a parabola. The minus 2 shifts it right by 2 units, and then the plus 4 we have on there shifts it up by 4 units. Okay? And then over here for f of x, we can start with the square root of x as my base function. Okay? And we know that the minus 4 will push this one to the right by 4, and then the plus 2 at the very beginning shifts it up by 2. So let's use these particular properties to draw this graph. And then just before we do that, let's try to remind ourselves for f of x here for a second. What's the domain for this? Well, with that square root, I know that x minus 4 has to be bigger than or equal to 0. And if you take that 4 over to the other side, that says x has to be bigger than or equal to 4. So what that means is when I use my graph, I want x to be 4 and everything bigger than that. So this is what my domain is going to be for my original function f of x here. All right? So let's think about what these things are going to look like. All right. So again, f of x is going to take my basic square root function, right, which looks like this thing. It's going to shift it 4 to the right, so it'll be 1, 2, 3, 4 to the right, like this, and then up 2. So it'll look something like that. Okay, so let's move those over, 1, 2, 3, 4, 2, and it's going to look like this. Right? So that's the point 4, 2. Right? This is the point 5, 3, and so on. Right? So if we look at f of x, right, we said the domain goes from 4 on out to infinity. And then if you look at the picture, if we want to actually find the range, it looks like the smallest range value is 2, and then it keeps on going up from there. So it looks like the range goes from 2 to infinity. All right, so now let's think about what f inverse is going to look like. Again, it's our basic parabola that is shifted right 2 and up 4. So this point right here, 0, 0, will get shifted 2 to the right and up 4. So 1, 2, 3, 4, which might be right there. Right? And then there's what that parabola would look like. Okay? Now, hopefully little bells are going off in your head saying, oh, that inverse there, that red function, it's not 1-to-1. Correct, because if you remember for f inverse, the domain is just going to be the range that we had for the function. So it's just going to go from, let me get rid of that. It's just going to go from 2 out to infinity, and the range is going to go from 4 to infinity. So in other words, for f inverse, I'm only going to use these points from 2 on out to there. Right? So all this stuff that we had over here to the left of 2, it is gone. All right. So that's what our two functions then look like. Right? And if you remember, we switched the x's and y's to actually draw this thing and to generate our function. If you actually graph the line y equals x, it's going to go right through those two things like this. Right? So there's the line y equals x. Right? So this shows me that one thing I can do to draw the inverse from f is I can reflect f of x about the line y equals x. And that will generate the inverse for me. Right? So if you look at the picture and put them both on the same graph, this is what it should look like. Right? One graph should be the exact same thing as the other when you flip it about the line y equals x, which means if you take every ordered pair and switch them, that should be on the other one. For instance, on the square root, we had the point 4, 2. Ooh, right here, that's the point 2, 4. And this point 5, 3, that's this point 3, 5. Right. So let's look at one more of these pictures and then we'll wrap it up. The function f of x equals x cubed looks like this. Okay. If you notice for this function f of x equals x cubed, it is always going up. Right? And if you ever have a function that's either always going up or always going down, then it has to be 1-to-1, which means it has to have an inverse. Right? So for the inverse for this thing, right, if I said y equals x cubed, to find the inverse, let's switch the x's and the y's, and then take the cube root of both sides to give me this. Y equals the cube root of x. Right? So in this problem, the inverse is the cube root of x. Okay. Now, what's that going to look like if we draw it? Well, on this function y equals x cubed, I've got this point 0, 0. Here's the point 1, 1. Here's the point 2, 8. There is -1, -1. And there's -2, -8. To graph the inverse, all we have to do is take these ordered pairs and flip them. Okay? So that point 0, 0, it gets flipped to 0, 0. 1, 1 is still going to be 1, 1. 2, 8 comes over here to 8, 2. So it's going to look something like this. -1, -1 stays at the same spot. But then -2, -8 gets flipped to -8, -2, which is down here. So it's going to look like this. And if you're wondering, yes, it does go about that line y equals x, because y equals x looks like this thing. All right, so again, if you have a picture of a function f and you know it has an inverse, a quick way to get the graph for the inverse is to take every ordered pair and just flip them. All right, so again, 1, 1 stayed at 1, 1, 2, 8 became 8, 2, 3, 27 would become 27, 3, and so on. So just flip all of those points, connect your dots, and if you notice the green that we have on there, the green part shows me what my inverse is going to look like. All right, so that's it. A bit of a review to get us going and some new stuff as well. We are going to be working in section 1.7, I believe, in our book, and I'll post the homework up on Moodle, but I hope you guys got something out of it. If you need any help, of course, always come by and see me, and if not, I will catch up with you in class. Talk to you later. Bye-bye.